Hi, I will discuss a question. A coil of cross-sectional area A, number of turns N and resistance R is placed with its plane perpendicular to a uniform magnetic field B. If it is rotated through 180 degree in time delta t, you are asked to find out the induced EMF, induced current and the induced charge. This is a question you have to do. Based on this question, you can try NCERT example number 6.3. Okay, now we will see this question. Now there is a possibility of mistake you tend to make. Plane perpendicular. Okay, this is one important point you have to understand. We have the formula for magnetic flux phi is equals BAN cos theta. What is theta here? Theta is the angle between magnetic field vector and area vector. Theta is the angle between magnetic field vector and area vector. Now let me show this idea in figure. So let me consider this is the direction of the magnetic field. And here you can see that the angle between the plane and the magnetic field is 90 degree. This is where I am saying plane is perpendicular to the magnetic field. Plane perpendicular to the magnetic field. Plane is perpendicular to the magnetic field. So which means the angle between these two is 90 degree. Angle between the magnetic field vector and the area vector is 0 degree. Angle between plane and magnetic field is 90. The angle between, so this is the direction of the magnetic field vector. Obviously this should be the direction of the area vector as well. Which means area vector is parallel to the magnetic field vector. So initial angle is equal to 0 degree if I take. Then what will be final angle? Now it is rotated through 180 degree. Final angle will be 180 degree. Initial flux is equal to BAN cos 0. Final flux is equal to BAN cos 180. Change in flux delta phi is equal to phi f minus phi I. In phi f and phi I you can take BAN common factor. So this is BAN into cos 180 minus cos 0. As you all know, cos 180 minus cos 0 is cos 180 minus 1, cos 0 1. This is minus 2 BAN. We have a lot of problems having this concept involved. Minus 2 BAN. Now you can calculate induced EMF is equal to minus delta phi by delta t. This is equal to 2 BAN divided by delta t. 2 BAN by delta t is the induced EMF whenever you find coil rotated through 180 degree with the plane initially perpendicular to the magnetic field or area vector parallel to the magnetic field. Now current I is equal to epsilon by R, which is very simple, 2 BAN by R delta T. And we know that induced charge delta Q is equal to minus delta phi by R, as we have learned in the one of the previous video. Delta phi is this much. This is 2 BAN divided by R. See these all formula are very important and I would request you to keep this in your formula book. These are the answers to your questions. Delta phi Q is equal to del minus delta phi by R. This is 2 BAN by R. This is 2 BAN by R delta T. This is 2 BAN by delta T. Now we will see another situation that is coming as example number 6.6. It's a very important example, I tell you. Rod rotating in a uniform magnetic field. Rod rotating in a uniform magnetic field. So So I'm going to use another method for solving this. Rod rotating. In uniform magnetic field. Rod rotating in a uniform magnetic field. Consider a situation where there exists a uniform magnetic field. Okay, let me consider a rod of length L is rotated in the anti-clockwise sense with an angular speed omega. So as I used to do, I will limit the use of integration here. According to our knowledge, we have seen that the induced EMF epsilon is equal to BLV for a rod moving with a velocity v. Right? Rod moving with the velocity v, its induced EMF is BLV. In this case, I will say VCM. BL into VCM. Anything wrong here? Now from the figure I can say VCM is equal to L omega by 2. VCM is equal to L omega by 2. Which means what is going to be the induced EMF epsilon is equal to simple B L square omega divided by 2. Problem is over. This is the answer for induced EMF. Now the question comes. So what should be, which end should be positive here? Which end of the rod is going to be negative here? Now here, this is rotated with an angular velocity omega means this is the direction of the velocity of the rod. This is the direction of the velocity. Now according to the Fleming's left hand rule, these electrons will experience. So let me tell you, electrons. So velocity of the rod is in this direction means we have to take the current of the electrons in the opposite direction. So electrons will experience a force in the upward direction. Electrons will experience a force in the upward direction, which means this end of the rod is positive, this end of the rod is negative. So which means if I say this as A and B, so here I have to say that VA minus VB is equal to plus BL square omega by 2. VA minus VB is equal to plus BL square omega by 2. So always this end is at a higher potential when it is rotated in the anti-clockwise sense. What will be your answer if it is rotated in the clockwise direction? What will be your answer if the rod is rotated in the clockwise direction? If it is rotated in the clockwise direction, B will be at a higher potential than A. Ready? So that's the answer we can say. So in this case, VA minus VB is equal to BL square omega divided by 2. That's the formula for induced EMF. Now let us consider another situation of this one. Now this is one rod. This is another rod which are of same length L. Now this is C. So question I am asking is, so in this problem, so the whole arrangement, this is a rigid arrangement. This is rotated with an angular speed omega. You are asked to find out VA minus VB and VA minus VC. So let's solve it. What we will do here? We will treat each rod as a separate rod. Now in this case, both are of same length L. This length is also L. In this case, I can say this will be equal to VCM is equal to L by 2 omega. Here also VCM is equal to L by 2 omega. Okay. So what I can say VA minus VB, just like I did earlier, VA minus VB. Treat each rod separately. Don't think that there are two rods and so it is a complicated problem. I will tell you, just think like this rod is not present. The rod AC is not here. Just consider rod AB only exists. So in this case, VA minus VB is equal to BL square omega divided by 2. That we have seen in the previous discussion. Now, what will be VA minus VC? Okay, obviously it is rotated in the anti-clockwise sense, which means A should be at a higher potential compared to C. As it is rotated in the anti-clockwise direction, A has to be at a higher potential compared to C. So what will be VA minus VC here going to be? Again, it is going to be BL square omega divided by 2. right? So question which I'm asking is, what is VB minus VC equal to? VB minus VC. What will be VB minus VC is equal to? Answer is very simple. If you just take the difference of these two equations, this will come out to be 0. Taking the difference of these two equations. So suppose if I got another rod here, say of length D, what will be VC minus VD equal to? Again here I can say, as it is rotated in the anti-clockwise sense, VA minus VD is equal to half BL square omega again. Right? So which means VB is equal to VC is equal to VD. Because if you take the difference of these two equations, again we can see that VC minus VD is equal to 0. So these points are all at the same potential. Now what I am going to say here is that if you consider a ring, and these are all diameters of this ring, I can say that every point of this ring will be at the same potential. Every point of this ring will be at the same potential. Every point of this ring will be at the same potential. So this potential will be equal to BL square omega by 2. This is also going to be BL square omega by 2. This is going to be BL square omega divided by 2. Everything is going to be BL square omega by 2. So what does that mean? So that means potential difference between center and a point on the periphery is BL square omega by 2. Potential difference between a point between center and a point on the periphery is BL square omega by 2. This is what you can see when a cycle wheel is rotated. What is the induced EMF on each spoke? It is going to be same, and your answer is going to be half BL square omega. Based on that, I will tell you, try example number 6.7 from NCERT book. Example 6.7 you can try based on that. So that is an important point I want to say here regarding a rod rotating in a uniform magnetic field. Now we will discuss another important topic. Perhaps it is given at the last of this textbook, but I think I can discuss along with this one. This is nothing but AC generator. So this will enable us to study about AC in detail. Now what is an AC generator, or we say electric dynamo, as designed by Sir Michael Faraday, who is known to be the king of experiments, like Millikan. Michael Faraday has done a lot of investigatory projects. Now what is an AC generator? AC generator. AC generator is a device that is used to generate AC. A device that generates AC is what is called an AC generator. An AC generator works on the principle of electromagnetic induction. Let us construct an AC generator. The basic arrangement of an AC generator involves the pole pieces of a magnet. Now let me say this is initially I am saying that the plane of the coil is held perpendicular to the magnetic field. Plane of the coil is held perpendicular to the magnetic field. Plane of the coil is perpendicular. So this is the discussion I am saying. First thing you have to understand is that plane of the coil perpendicular to B. Plane of the coil is perpendicular to B. Now the coil is, what I am saying is, coil is rotated with an angular speed omega. So what is initial angle? Plane of the coil is perpendicular to the magnetic field means the initial angle is 0. Angle between the area vector, as we have seen at the beginning of this session, the angle between the area vector and the magnetic field vector is 0. So at t equal to 0, theta is equal to 0. That is, theta is the angle between the magnetic field vector and the area vector, that is 0. Now the second thing I am saying, at time t, the coil has rotated through an angle omega t, right? So initial angle is 0. As the coil has rotated through an angle omega t, in this case the angle turned by the area vector is also going to be omega t, right? When plane has turned through an angle omega t, area vector also should be turned through an angle omega t because they are mutually perpendicular. When this rotates through an angle t, omega t, the other thing also should rotate by the same amount, right? So theta is equal to omega t. So I can say instantaneous flux phi is equal to BAN cos omega t. Now I can see at t equal to 0, theta is equal to 0. So initial flux is BAN. So flux phi is equal to BAN cos omega t. So I said initially the plane of the coil is perpendicular to the magnetic field. Initially the plane of the coil is perpendicular to the magnetic field. Initially the plane of the coil is perpendicular to the magnetic field. I am saying time and again because you have to understand this clearly. Initially the plane of the coil is perpendicular to the magnetic field. So the flux phi is equal to BAN cos omega t. My question, what will be the induced EMF epsilon is equal to minus d phi by dt. This is equal to what? BAN omega. The derivative of cos omega t is minus omega sin omega t. I have one more minus here. So those two minus will go. BAN omega sin omega t. This is the formula for induced EMF. Ready? This is a formula for induced EMF I am saying. Now this may be written as epsilon 0 sin omega t. Epsilon 0 sin omega t. Now what is epsilon 0? This equation resembles the equation of SHM like x is equal to a sin omega t, where a is called amplitude, displacement amplitude. Here, what will be epsilon 0 called? The term epsilon 0 is called peak value of EMF. Peak value of EMF or peak value of voltage. Epsilon is equal to epsilon 0 sin omega t is called the peak value of the voltage or voltage amplitude here. Now see this expression. Epsilon is equal to epsilon 0 sin omega t. You are given an equation. The equation of EMF produced by an AC generator is epsilon is equal to epsilon 0 sin omega t. What is the initial angle between the plane and the magnetic field? What is the initial angle between the plane and the magnetic field? Angle between plane and the magnetic field is 90 degree. So for getting this expression, initially the plane is perpendicular to the magnetic field. Plane is perpendicular to the magnetic field. So please understand this. So what does that mean? The AC voltage. From here you can understand an important point that epsilon is equal to epsilon 0 sin omega t, which means this voltage varies sinusoidally with the time. Sinusoidally. As you have studied in trigonometry regarding a sine function, if I plot a graph between epsilon and t, the shape of the graph should be something like this. This is 0. This is pi by omega. This is 2 pi by omega. The time is, right? So this much is 180 degree. Omega t is equal to pi. So t is equal to pi by omega for a half cycle. This is called a positive half cycle. This is called a negative half cycle. Now, this is one idea to understand regarding an AC generator. The second case I am saying the plane of the coil is parallel to the magnetic field. Parallel to the magnetic field means the initial angle. Area vector is then perpendicular to the magnetic field. So initial angle is at t equal to 0, not theta. Initial angle is 90 degree. At t equal to 0, the initial angle is 90 degree. Now at any time t, it will rotate from this 90. So omega t plus 90. In this case, sin 90, cos 90 plus theta. So BAN cos 90 plus omega t that is equal to what you get, minus BAN sine omega t. In this case, after differentiation, you will get one minus here, another minus comes here, cos omega t. Suppose you are getting an equation like this, epsilon is equal to epsilon 0 cos omega t. What do you need to understand? You need to understand that, so if epsilon is equal to epsilon 0 cos omega t, in this case, at t equals 0, the plane of the coil is parallel to the magnetic field. Epsilon is equal to epsilon 0 cos omega t is the equation of EMF, means at t equal to 0, the plane of the coil is parallel to the magnetic field. If epsilon is equal to epsilon 0 sine omega t, at t equal to 0, the plane of the coil is plane of the coil. Please understand the words I am using. The plane of the coil is perpendicular to the magnetic field. So please mind these expressions. If it is given like epsilon is equal to epsilon 0 sine omega t, which means at t equal to 0, plane of the coil is perpendicular to the magnetic field. If you are given an equation like epsilon is equal to epsilon 0 cos omega t, then at t equal to 0, plane of the coil is parallel to the magnetic field. So this is an important thing you have to understand regarding an AC generator. So for this function, the shape of the graph, I am not drawing, I leave that graph to you, because you know the cosine graph as you studied in trigonometry. So this is the idea regarding AC generator, and let me tell you, an AC generator is a device which generates AC, or which is a device which converts mechanical energy into time varying electrical energy. The detailed aspect of this chapter we will discuss in the next chapter, but I took this because in an AC generator, because this is on the basis of the Faraday's law of electromagnetic induction. In an AC generator, magnetic field is a constant, area vector is a constant, number of times is a constant. AC is generated because of the change in orientation. Change in orientation. AC is generated as a result of the change in the orientation. Okay, so I think it is not getting clear because the board does not have sufficient friction. So it is due to the change in orientation. So it's a case of an EMF induced as a result of the change in orientation. So this is what is regarding an AC generator.